Hello and welcome to this session about database locking and locking strategies. We're using the Progress OpenEdge ABL and the Progress OpenEdge RDBMS for this demonstration. We have two instances of the application in front of us, running the exact same program against the exact same database, which is the Sports 2000 demo database, which is shipping with the Progress ABL. At the bottom we have the Progress OpenEdge database monitor open, and specifically on the record locking table, so that we can see when the records are locked by the two applications above. So let's select a customer in the first window. We can see that this is user number 7 and he locked the record with row ID 98 in the database with a share lock. I can select the same customer in the other window, and now we'll see user number 8 locks the exact same record with a share lock. This means a share lock allows us concurrent access to the record. Both can read the same record. Now, let's say we want to change the fax number on this customer, and we update it and we commit the transaction. We get a message telling us that we can't do this, and we can see in the locking table at the bottom we tried to upgrade the share lock to an exclusive lock, but we have to queue for it because somebody else still have a lock on this record. In other words, the share lock now causes record contention, but we have consistency. The user on the right knows that the record can't change while he's using it. If we release the record on that side, the user on the other side will be able to commit the change and the lock will go away. We can also read the record with an exclusive lock from the beginning. If we do that, we'll see that we have an exclusive lock on this record, and the other user can try to read it with a default share lock, but won't be able to, because only one user can have an exclusive lock at any given time, which means of course that we won't be able to read it with an exclusive lock either. We can however specify that we want to read the record with no lock. In other words, we're not locking it at all, and at the bottom you can see user 8 doesn't have a lock, but he does have the record. Of course, you will not be able to update the record if you don't have a lock on that record, because you do need a lock in order to change a record. Even if this record is released by that user, this one will not be able to continue. Let's do that again. See, since we don't have a lock, we can't update the record. So when it comes to record locking strategies, we have optimistic, default and pessimistic in the OpenEdge ABL. With default locking, records will always be read in share lock mode. With pessimistic locking, we always assume the record will change and always lock the record. While that causes high consistency, because nobody else can read the record if we use a pessimistic strategy, it also causes contention. But at least if we now change this, say this fax number is 0 there, and we commit it, the other user will eventually be able to obtain the log. You will see the update that we've done. The problem is, while somebody is busy with a record, nobody else can access it in a pessimistic strategy. On the opposite end, we can follow an optimistic strategy. With an optimistic strategy, we always read the records with no lock. As you can see in the record monitor at the bottom, neither one of these has locked the record. But we've seen earlier that with no lock we cannot update the record. So how does this work? Let's once again take the phone number and modify it slightly to get a fax number here. And let's on this side add an email address. Okay. So when I commit the record on this side in an optimistic locking strategy, we actually read the record again, lock it, update it, and release it. That happened so fast that with the 1 second interval we have in the monitor below, we didn't even see it happen. Now, what happens if the second user who read the same record wants to update it? Notice that after the record has been updated, the fax number is there, but the email address is missing. So let's copy that fax number. So now in this window, when I commit the transaction, we will get a message which is not normal for an application, because it gives you options that you should normally not give a user. First of all, I tell you that the record was changed, because when we read the record again in order to lock it, we must check if it changed, because the optimistic locking strategy assumed that it wouldn't change. So we read it with no locks. We had high concurrency, but low contention. Okay. So now we see that it did change, and the correct thing to do is to give the user one of two choices: redo the update or cancel the update completely. In this case, I allow you to commit it regardless. That is normally what would happen if you forget to check if the record changed before you commit. So, did the record commit? Let's see. It did. But notice, the fax number, which we've read here, is now gone. Why did that happen? Well, we lost the update. Because originally, both sessions read the record without a fax, without an email. The first session changed the fax number. The second session changed the email and did not check whether the record changed, but just committed it regardless, which means the blank which was on the screen was committed back to the database, and the update on this side was lost. So if we go back to the record, we'll see now that the record has been updated in full. So let's change the discount percentage to 12% on this side. But this time it was changed by another user. Do we want to cancel or redo? If we say redo, the record gets displayed again, but as you can see, we have the latest version, and now we can do the update and it will go through. If we read it again, we'll see that the update was committed. On this side, let's change the address. It was changed by somebody else. If I cancel, Let's go back. We'll see that the discount percentage is still 12%, but of course the unit number was not updated. This concludes our session about record locking, concurrent access, and consistent data views. I hope you enjoyed it. Thank you very much.